Corrosion, and I'm currently studying PhD at Darwin University. And today I want to talk about one of my research projects, the effect of pH regulation by microbes on corrosion behavior of material in acidic environment. So in engineering applications, corrosion is one of the biggest problems that all engineers have to face for a long time. And here is the chart that the corrosion cost of different industry. And the total cost of corrosion cost per year is 276 billion. That's a really huge amount of money that all industry have to pay because of corrosion. So what is corrosion? So corrosion is the series reactions between environment and the metal and result in deteriorating material, like leaving a different kind of piece on surface of material with different shapes, like narrow piece or shallow piece. The videos here show one kind of corrosion failures, very severe corrosion failure. So that's the corrosion. So what is microbial corrosion? So microbial corrosion is the involvement of bacteria in corrosion of material. So how bacteria can corrode the material? Do they eat material? No, actually they don't. So when the material is exposed to environment, the bacteria from environment will attach to the surface of material. Then they will develop the biofilm on the surface of material, and during time the biofilm will be thicker and thicker, and underneath the biofilm, because of bacterial metabolism, they will change the local pH and some metal properties, then that results in corroding material. So in my research, I did with sulfate reducing bacteria. So this is one of the dominant bacteria in causing corrosion, microbial corrosion. So as its name is a sulfate reducing, so it absorbs sulfate from environment and produce sulfate. So sulfate can be in hydrogen sulfate or sulfate ion, and thus this sulfate can combine with metal ion to form metal sulfate, which is a corrosion product. So sulfate reducing bacteria in previous literatures, they show that they can live in acidic environment. So in acidic environment, for example, in acid river, might telling acid drainage. So and there are a lot of equipment that to work under acidic environment. And you know that when metal working under acidic environment, it's very easily to corrode, dissolve the metal and corrode the metal. So if and other literature shows that sulfate reducing bacteria have ability to change the pH of acidic environment to neutral environment, to pH neutral. So if material works in acidic environment with presence of sulfate reducing bacteria, will they affect the fact that in acidic environment the corrosion rate of material is high? So that's why I conduct this research. So in my research, I will conduct with two parallels. The metal is the double stainless steel 2205, and two parallel containing artificial seawater and both bacteria, sulfate reducing bacteria. And that one parallel I put at pH 4, very low, very acidic environment, and one is at pH 7.4 for comparison. So and during experiment, I will measure the sulfate level in each parallel and pH in each parallel, counting bacteria. And after that, I also measure the ferrous ion, dissolved ferrous ion in each parallel after 5 days and 13 days. And finally, I took the metal compounds out for scanning electron microscope. And the result is really amazed me. Here is the triple result. So as you can see here from the pH graph, in the pH 4 parallels, after around 5 days, bacteria already changed pH from around 4 to nearly 7, and after that they remained at around 7.5. That's really great. And for sulfate level and bacterial enumeration, so the point to note that for the first 5 days, bacteria did not really produce sulfate, and the total bacteria in the solution did not increase much. So why is that? Why bacteria did not do anything for the first 5 days? So this can be explained by the word cell soft. So when the bacteria is exposed to very acidic environments, they were very soft because they prefer neutral environments. So they did not do anything. So did not really do anything. And once after 5 days, when the pH increase a little bit, and then they adapt, they can adapt to the environment, and they start produce very quickly. So that's why we see here very high, quickly increasing in bacteria, and also they produce a lot of sulfate. Another interesting to mention is that the sulfate produced in pH 4 porous is much higher than the pH produced in pH 7.4 porous. So why is this? The reason can be explained by this reaction. So sulfate-reducing bacteria, they consume sulfate and hydrogen to produce sulfate. So in pH 4 porous, there is very high concentration of proton. So high concentration of proton, and bacteria use that proton and sulfate from environment for their metabolism, and they produce a lot of sulfate because high proton concentration. This is scanning electron microscope results. So we can see here HPF for the metal compounds immersed in pH 4 porous. We can see some beating on the surface, and here is some corrosion product and some mixed with the biofilm. But when the metal compound immersed in pH 7.4 porous, they just saw like very thick biofilm on the surface. So it means in pH 4 porous, they have corrosion process happen and very severely. So they leave very pit here, and energy dispersed X-ray show the result that they saw on the surface here they have sulfate, while here they don't have the very high bit of sulfate. So it means here is corrosion product mixed with the biofilm. Another reason is the concentration of ferrous ion. So ferrous ion dissolved because of bacterial metabolism. They can dissolve to the solution, and if the concentration of ferrous ion is high, it means that the corrosion rate of that material is high. So here we can see that the compounds immersed in pH 4 porous. For the first 5 days, when the pH still below 7, the concentration of dissolved iron is very high. It's nearly 82. So while in pH 7.4 is very low. But after 5 days, when the pH of the pH 4 porous they reach 7, and the concentration of ferrous ion just increase, just small increase. So it means that when the pH increase because of bacteria, the corrosion rate of material has been decreased. So in conclusion, my experiment has shown that this sulfate-reducing bacteria have ability to regulate the pH from 4 to 7, around 7.5 after 5 days, and they have ability, because of that ability of regulation pH, they lower the corrosion of material, in acidic environments. So, here is the reference I use my presentation. So thank you.